Okay, hello. Hello guys, so today we'll be solving additional math paper 2, okay, variant 21. So again, you have 2 hours and formula page on the second page. So let's look at the first questions. On the axis, sketch the graph. Y is equal to the modulus 4x minus 6. So showing the points where the graph meets the axis. So you have to clearly state where's the points of intersection. So whenever you see the word meets the axis, always you have 2 rules to remember here. Either you let x is equal to 0, find out the y, or y is equal to 0, find out the x. Okay, and you may need to do both. So let's try to attempt these questions without considering the modulus first. 4x minus 6. So when x is equal to 0, our y will be 4, 0 minus 6, it will be negative 6. So 0, negative 6 will be one of the coordinates here. Right? I will just simply label here. And then when, let me just draw partitions. When y is equal to 0, what is our x? So y is equal to 0. 4x minus 6 is equal to 0. 4x is equal to 6. X will be equal to 3 over 2, I guess. Okay, so that will be around 1.5. So it will be around here, 1, 1.5. 1.5, 0. Next, just draw the line until it reaches up there. Okay, so make sure you do label for x minus 6. But remember, we are dealing with modulus functions. We need to basically make sure that the 0 minus 6, okay, will be flipped upward. So it will be around 0, 6. And afterward, continue the entire line, finish this up, and use the dotted line to represent, or you can either erase everything, but I will just leave it to show the examiner that these are just the dotted lines. Okay, so after you've written down everything, just make sure you put the modulus functions. Okay, so that's basically for the first one. Now, second one, solve the equations modulus of 4x minus 6, modulus 2x. So how do we solve this type of questions? So when you see there are actually modulus functions on both sides, the left hand side and the right hand side, so we can actually square them, right? Just square both sides and then you're good to go. So that would be 16x squared, so minus 48x plus 36 equivalent to 4x squared. 12x squared minus 48x plus 36 is equal to 0. So we can either make the number smaller by factorizing, or you just divide everything by 4. Okay, so including the right hand side, but it's going to be 0 anyway. So that's going to be 3x squared, 12x plus 9. Okay, is equal to 0. I guess we can also even reduce them by 3. Okay, divide by 3 on both sides. X squared, 4x plus 3 is equal to 0. So now we can solve the quadratic equations. Minus 3, minus 1. So you'll end up with x equal to 3, x is equal to 1. Okay, do we need to draw partitions? Okay, just to be safe, you should be able to check your answer anyway. Okay, just check where, especially when you're at the negative values, right? But I guess in this case I'm not going to, because I sure will get positive values on both sides. So I guess for this one we don't really have to check. Okay, let's move on. So question number 2. Write 3 plus 4x minus 2x squared in the form of, this is actually the CTS form, the so-called completing the square form. Okay, so there are so many ways of doing it. I think your teachers are explaining this to you guys as well, but we'll be using something what I think is simple. So rearrange them, make sure the coefficient of x squared is in front, 4x plus 3. So first focus on the first two terms here, factorize out the 2, x squared, and then the middle one will be minus 2x plus 3. Okay, and then you'll need to put 2 plus bracket square minus bracket square, close the square plus 3. So what is the second term here? Minus 2, just put it in. Okay, and so you will have minus 2, okay, bracket x, move the entire thing here, minus 2 over 2, there's going to be negative 1, close the square, minus, okay, then this will be minus 1 square, okay, close the bracket, plus 3. Okay, so we still have the bracket here. Now bring in the negative 2, so this entire thing will be 1, so that will be plus 2 plus 3, so you're gonna end up with negative 2, x minus 1 square, plus 5. Second one, hence write down the range of functions, 3 plus 4x minus 2x squared. So as you know, because the coefficients of x squared is negative, so this means that you're gonna get a negative curve, right? A sad phase. So within the sad phase, there's a maximum point. So how do we determine the maximum point by using the CTS form? So just take the CTS form, okay? So this is basically the functions fx. Hold on, let me just write the fx properly here. So we'll need to pay attention to this one, x minus 1 here. So just let x minus 1 be equal to 0, and therefore x will be equal to 1. How about the y coordinate? It would be just y is equal to 5. So the maximum point will be 1 and 5. So how do we find the range of this? For sure, this is the maximum point. So any values or any points on the graph will be lower than, any y values or fx value will be lower than the maximum point. So this is how you should write it. Range of fx will be fx is less than, okay, less than or equal to 5. Okay, less than or equal to 5. Okay, use algebra to show that the equation 5x bracket x minus 3 is equal to 5x minus 26 has no real solution. So this is another question that we have to use the determinant. Discriminant for b squared minus 4ac must be less than 0. So this is the conditions where the curve doesn't intersect the graph or something. So there is no real solutions when the d is less than 0. So first, I guess this is rather straightforward as well. You just have to expand everything. So that would be 5x squared minus 15x, 5x minus 26. So just move everything to the left hand side. So we're going to get minus 28, 20x squared plus 26. Now, the first term, the coefficient will be 5. B negative 20, C is 26. So using the formula, D is equal to B squared minus 4AC. We just have to check that, right? So minus 20 square minus 4 AC. I'm just going to punch it into the calculator. Minus 20. How can I mute the sound? Hold on, just give me 1 second. Minus 20 square minus 4. Oh, I like this calculator more. So easy to use. So D will be negative 120. So this is clearly the evidence. Since D is less than 0, therefore there is no real roots / solutions. Okay, no real solutions. Okay, question number 4. Do not use the calculator for these questions. Find the exact distance between 2 points where the curve cuts the y-axis. So whenever you see the word cuts the y-axis, you know that the x-coordinate is going to be 0. Okay, because let's say you have a curve. Okay, you have a curve. So this is the exact 2 points where it cuts the x-axis. So x will be equal to 0, regardless, nonetheless. Now, we have to look. Just replace the x equal to 0 in there, and then what you will get is 9, 0 minus 1 square plus 4, y minus 3 square is equal to 36. So 9 plus 4, y minus 3 square, 36. Then move the 9 to the other side, it will become 36 minus 9, 27. Y minus 3 square, 27 over 4, right? So be careful whenever, let me just draw the partitions. We have to move the square roots, okay, to the other side. So reciprocal of 2 is going to give us like square root 1 over 2, right? When we put this, please remember to put a plus and minus. Okay, otherwise we will lose marks for not writing it down. So according to certs, that will be cert 27 over 2, or y minus 3 is equal to minus 27 minus cert 27 over 2. So move the 3 to the other side, then you will have your y coordinates. That's the first one, and that's the second one. Now, how do we find, since we know that x, the coordinate of x is already 0, so might as well just write down the coordinates, but we have to find the exact distance, right? So we can't really do anything at this point, so just mark down the coordinates first. 3 plus 27 over 2, so I'll call this as coordinate A, then B as 0, 3 minus 27 over 2. Alright, since we already have our A and B, so we can pretty much do this. Okay, just mark this one as x1, y1, and the other one as x2, y2. So distance AB will be equivalent to y2 minus y1 square plus x2 minus x1. So how do we do this? Close up the bracket. Y2, that will be 3 minus 27 over 2 minus, put the bracket to be safe, then square both sides. So we can pretty much ignore the 0 because it's gonna be, the x is gonna be 0 anyway. So label it down. So this will be cancelled out. So we're gonna have negative 27 square. So that will lead us to cert 27, or since it's 9 times 3, so it's gonna be 3 cert 3 units. Okay, you can represent your answer in either both ways. Okay, for the next one. Okay, the next one. There are 3 women, 2 men, and 4 children in the choir. The choir stands in a single straight line. Find the number of possible arrangement if the first and last persons are both women. So when you see the word arrangement, technically this is a greatest hint to show that you're gonna do permutations. Okay, permutations. So you have to do this regardless. Now, what do you need to do first? Just basically draw out the possible arrangements. Okay, in a straight line. So both will be woman and woman. So note that there's only 3 women here. So out of 3 women, you only have to choose one. And the second one, Once the first woman is already here, so the second one you only have 1 to choose from, so that's why it's called 2p1, right? So the remaining would be 7 factorial, and they are bound to change places as well. So they have so many ways of arranging them. So 3p1 times 7 factorial times 2p1. So 3p1 technically is still 3. 3 times 7 factorial times 2. That's going to give us 3 times 7 factorial times 2. 30,240 ways. Find the number of possible arrangements if all students are standing next to each other. So we just put all women standing. Is it all children? Oh, my bad. All children are standing next to each other. So you can technically group them as one whole group. So they will move around all places. 1, 2, 3, 4, 5, 6. Out of the 6 column, they'll move together, right? So how many more places can they move? 1, 2, 3, 4, 5. So 6p5. But don't forget that the child inside can also interchange places. So just multiply by 4 factorial, then you'll get your answer. So 6p5 times 4 factorial, right? So that's gonna be 17,280 ways. Now for part B, 4 of the choirs are selected to sing in a group. Find the number of different selections if no man is chosen. So we need to choose 4, so it's best to draw tables so you guys can see. Of course, if you guys have a faster way, you can just skip, not draw the table, but rather just calculate and then just punch in the combinations. So children, but I'm just going to show you how it's done. Okay, for those in case you are struggling with this, you can choose to do it like me. So we don't want to choose any man, doesn't matter. So the total number has to be 4. So it can be 3, 1, 0, 2, 0, 2, okay, 1, 0, 3. Or I can basically choose no woman, okay, no men, but all of them are children, right? So this is also the combinations. So what do we need to do here? 3, just take the total number of women, C3, follow here, times 2c0 times 4c1. Okay, do this for the rest. 3c2 times 2c0 times 4c2, and then the other one, 3c1 times 2c0 times 4c3, and last but not least, that is 3c0 times 2c0 times 4c4. Okay, so anything to c0, okay, 0. So 3c3 is basically 3, c3 is basically just 1, 2c0 is also 1, I guess. Yep, 1, so that would be 4. 3c2 times 4c2. So that's going to be 18. 3 times 4c3. So that's 12. 3c0 times 2c, both are 1 anyways, so you can't really do anything. So 4c4 is also 1. So the total number of ways, just add up 4 plus 18 plus 12 plus 1. So we're going to end up with 35 ways. Right? So again, do the same thing, but now we need to have at least 2 women. So draw the same table. At least 2 women, so meaning you can the woman has to be 2 or 3. But this time, mans are allowed. So let's do it here. Still, we are choosing 4 people in total. Okay, 4 people in total. So we have to choose at least 2 women. Okay, so we can play around basically like this: 2, 1, 2, 1, 1, or 2, 2, 0. Or maybe we can do something like 2, 0, 2, 0, 2, or 3, 1, 0, 3, 0, 1, but just not less than 2. Okay, so we just have to add up, I guess that's basically the possible combinations that we can have. So again, do the same: 3c2 times 2c1 times 4c1. Drawing the table is kind of like the insurance. I believe you guys have a lot of easier way, but in case if you're struggling with this kind of questions or you don't like it, the table can really help you a lot. Okay, so 3c2 times 2c2 times 4c0, 3c2 times 2c0 times 4c2, 3c3 times 2c1 times 4c0, 3c3 times 2c0 times 4c1. So add them all up. So 3c2 multiplied by 2 multiplied by 4, that's going to be 24. 3c2 multiplied by 1, 2c2 is going to be 1, right? I guess so. Times 4c0, which is going to be 1. So 3. 3c2 times 4c2, 18. 1 times 2, 1 times 2, that's going to be 2. 4c0 is 0. 4c0 is 1, sorry. 1 times 1 times 4, so that's going to be 4. So total ways, that's going to be 24 plus 3 plus 18 plus 2 plus 4. That's going to be 51 ways. Okay. Variable x and y are such that y is equal to cos x sine square x. Use differentiations to find the approximate change in y as x increases from 3 to 3 plus h. So whenever we see the word approximate here, we can straight away relate it to the formula dy over dx. The derivative of y will be equal to the approximation of y with respect to x. So the approximate, we can usually represent them by using the symbol sigma. And look at what the question wanted you to find. So they want you to find approximate change in y. So just focus on the y, move the x up, so that will be sigma y is equivalent to dy over dx multiplied by sigma x, right? So next, what do we need to do? We have to find, okay, I guess the difficulty comes from being able to solve product rule here. So u is equal to cos x, okay, v is equal to sine square x. So by using u prime, okay, u prime technically means du over dx, so that's going to be minus sine x. V prime, that is going to be, move the 2 to the front, and then reduce the power by 1. Then using chain rule, don't forget, the derivative of sine x is cos x, so just multiply with that. Then using by product rule, students should know the formula of product rule, u v prime plus v u prime. Therefore dy over dx is equal to cos x multiplied by 2 sine x cos x plus, what else is there? V sine square x, then sine x. So therefore 2 sine x cos square x minus sine cube x. But are we done here? Of course no. We have to replace the initial x value. Okay, substitute x equal to 3. So make sure, students, you put your calculator in radian modes, okay, for all the approximate questions. Okay, unless specified, right? But most of the time we'll need to represent our answer in radian mode. So sub x equal to 3 here. Let's find what's our dy over dx. 2 sine, okay, 3 multiply cos square 3 minus sine cube 3. So we'll see 2 sine 3, okay, it's in radian mode, right? I'm just scared. Cos square, okay, minus sine. So that's gonna be 0.2738. Pull it down, create a partitions. Now, sigma y is equal to 0.2738. So how about sigma x? Sigma x can be found by using, okay, the final value of x, which is 3 plus h, deducting the initial value of x. So that's going to give us h. So therefore, sigma y is equal to 0.274h. I represent my answer in 3 significant figure. Okay, for question number 7, it is given that y is equal to mx squared plus x over 2 plus n. So this is the equation given to you, where m and n are non-zero constants. It is also given that this whole thing, for all values of x, find the value of m and n. So they already give you guys the greatest hint, which is to find the derivative. So dy over dx, we can find the first derivative by doing this. So that will be 2mx plus 1 over 2, right? And use the same thing to find the second derivative, which is d squared y over dx squared. It's going to be 2m and 0. Okay, so this will be 0 as well. So just put it into the equation that has been given to you guys. So 2m, which is equivalent to dy over dx squared, which is 2mx plus 1 over 2 squared minus y. Just a quick one. So you will need to expand this, which is equivalent to 4m squared x squared plus mx. So there will be 2mx, right? 2mx plus 1 over 4. And the y here, we'll need to replace it with the original equations, which is minus mx squared. So I'm just going to move this over to the other side. So minus x over 2 minus n. So group all those with the x squared together. So that will give us 4m squared x squared minus mx squared. And group the one with x together, plus 2mx minus x over 2 plus 1 over 4 minus n. So for this one, it's a little bit tricky, but I would advise you to simplify or to take out the common term. So since this is x squared, so I would take it out to make comparison, 4m squared minus m. Okay, and I'll just take out the x as well, so I can compare 2m minus 1 over 2 plus 1 over 4 minus n. So for this one, you'll need to equate the left-hand side. Okay, equate the left-hand side with the right-hand side. Okay, so in this case, you can see that on the left-hand side, there is no coefficient of x squared. So we can basically just add by ourselves 0x squared here. Okay, so and in return, you have to make comparison. So 0x squared will be compared to the entire thing over here. Okay, so let me just use a different color and then show it to you guys how it's done. So 0x squared is equal to x squared 4m squared minus m. So cancel out, and that's gonna be 4m squared minus m is equal to 0. Factorize out the m, so you'll get 4m minus 1 is equal to 0. So you have two possibilities here. You can get either m is equal to 0 or m is equal to 1 over 4. But since m is a non-zero constant, so we have to reject this one. Okay, so this is rejected. Now we'll have to find the n. So n is in this, the last term, 1 over 4 minus n. And same thing, we'll have to equate means that we have to compare on the left hand side, which is only 6m. So 6m will be automatically compared to 1 over 4 minus n. Since m is equal to 1 over 4, so 6, 1 over 4, okay, 1 over 4 minus n. There you have 6 over 4, 1 over 4 minus n. Therefore, 1 over 4 minus 6 over 4, that is negative 5 over 4. So you will have negative 5 over 4 as your n, and m is equal to 1 over 4 as your m. So that's all for these questions. In an arithmetic progressions, okay, the sum of the first 30 term is negative 1065. The sum for the next 20 term is negative 2210. So find the first term, which is a, and the common difference. So how are we going to solve these questions? We can please note that the formula for a sum in arithmetic progression is n over 2, 2a plus n minus 1 multiplied by the common difference. So now we have sum to 30, that is 30 over 2 multiplied by 2a plus 29d, right? So that's going to be 15, bracket 2a plus 29d. So just move the 15 in, then you'll get 30a plus 29 times 15, that's going to be 435d. And given to us that the sum to 30 is negative 1065, so I believe everything can be divided by 5 to make it smaller. So that would be negative 213, 6a, 435 divided by 5, that's going to be 87. Let me check. I guess the whole thing can still be divided by 3 to make it even smaller. So that's going to be 71, 2a plus 87 divided by 2, that's going to be 29d. Just forgot my d here. Okay, so that's going to be our first equation, so we just leave it be. The second one, let's create a partitions. The sum to next 20 term is negative 2210. So it's just not just sum to 20, but rather than you have to take the overall. It means next 20 means that what is the next 20 terms of 30? That is 50. Sum to 50 minus by sum to 30. So this is the sum that we are talking about. So from here to here, that's sum to 30. From here to here, that's sum to 50. So what we need is basically this region. This is the sum of the next 20 term from 30. From n is equal to 30. So that's what we're looking for. So sum to 50. Oopsie. Let me make it smaller. Sum to 50, we can basically just use the formula again. So this is going to be 50 over 2 and 2a plus 49d. So 50 divided by 2, it would be 25 plus 49d. So 50a, 49 times 25, that's going to be 1205d. So that's not it. Since we know that sum to 30 is actually negative 1065, so the whole thing will look like 50a plus 1225 negative negative, so it becomes positive, is equivalent to negative 2210. So everything here can be divided by 25, I guess. Let me check. Yep, you can divide everything by 25. So that's going to give us 2a plus 49d is equal to 2210 divided by 25. Oops, I guess not. 2210, is it 2210? Negative 2210. Wait a second. No, there's no d here, right? There's no d here. So basically you can just find a by using this formula. 50a, it will be 50a plus 1225d minus, that will be minus negative 1065, that is equivalent to negative 2010. So just move this one over 1605, move this one over to the other side. So we'll get 2210 minus 3275. Everything just divided by 25. I think this should be it. So I get 2a plus 49d. 49d is equal to -1, 3, 1. Okay, so we can solve this by using elimination method. Just take the first one minus by the second one. So 2a plus 29d minus 2a plus 49d, that is equal to minus 71 minus 131. So 2a will be cancelled out. So 29 minus 49, that's going to be minus 20d. And negative 71 plus 131, that's going to be 60. So d will be 60 divided by 20, so that's going to be negative 3. So d is negative 3. So in order to find a, we need to just use either equation 1 or 2. So negative 7, I'm using 1 from 1. So negative 7, 2a plus 29 minus 3. So 29 times negative 3, move over, it will be 87 minus 71, that's going to be 16. So a is equal to 8. Okay, for question number 8, part B, the geometrical progression is such that the first term is 4, a is equal to 4, and the sum to the first 3 term is 7. No, it's not, sorry. Sum to the first 3 term is 7. And find the two possible values of common ratio and the sum to infinity to the convergent progression. So first, let's find out what is the value of common ratio. Note that in GP, the sum to arithmetic progression is a Rn minus 1, R minus 1, provided that your value of R, okay, is less than 1. Okay, so this is what we're going to use here. Let's see sum of n, so that's going to be 7. Okay, and we know that our a is 4, R, and it should be, oops, it should be 1 minus Rn. Okay, as we know, in GP, oops, our formula for sum is, it can be Rn minus 1, R minus 1, or Sn is equal to a 1 minus Rn over 1 minus R. So which one are we going to use here? So for this one, it's possibility that you will only use it when the value of R is clearly getting bigger, so more than 1. So for the second formula, it's only possible if your value of R is smaller than 1. So which one are we going to use here? Since we are definitely going to find the sum to infinity, and there's a converging progressions coming up which has the condition negative 1, R1. Okay, so there's a chance that our R might be smaller than 1, so we have to use the second formula here, the second one. Okay, so as the sum to the third term is 7, so the formula is given by 4, 1 minus R cubed, 1 minus R, I guess we'll be dealing with a polynomial right here. So 1 minus R, that is equal to 7. 7, 1 minus R. So 4, 4r cubed, 7 minus 7r. Move everything to the right, so that's going to be 4r cubed minus 7r plus 3. Yep, I guess that's pretty much it, right? Minus 7 is negative 7r plus 7. Yep, so we're gonna see which one is a factor. Apparently this is a polynomial. 7r plus 3 is equal to 0. So you can clearly see, let r is equal to 1. We test this out first. So we can see that if we put r is equal to 1 here, this is a factor. Okay, r is equal to 1 is a factor. So just use, you can do this with long division, so or you can just create a table like this, because I feel like this is faster. 4r cubed plus 0r squared minus 7r plus 3. So move this down, that's going to be 4, 0. Move this 4 up, 4 times 1, that is still 4. So 0 plus 4, that's going to be 4. Okay, minus 7, 4 times 1, that is still going to be 4, so move it up, plus 4. Negative 7 plus 4, that's going to be negative 3. Move the 3 down, and then negative 3 times 1, that is still going to be negative 3. Move it up. So the last one is 0. So this will be the coefficient for r squared, r and r to the power 0. So just put that down, r minus 1 multiplied by 4r squared plus 4r minus 3 is equal to 0. That's how you factorize this thing. But we're definitely not going to look at r equal to 1, since the r should be less than 1. So this is r minus 1 equal to 0. This answer is rejected. We're not going to look at that. But what is interesting is we have to deal with this one. So 2r, factorize this real quick. That's going to be plus 3, negative 1. Right? So r will be negative 3 over 2. R is equal to 1 over 2. So either one of them has the can give us sum. When n is equal to 3, the sum will be 7. But we're not done yet, since we need to look for sum to infinity of converging progressions. Remember that sum to infinity, the condition, it has to be, the value of r has to be in between negative 1 and 1. So the only r that fulfill these conditions will be r is equal to 1 over 2. So use this, a equal to minus 1, a divided by 1 minus r, a is equal to 4, 1 minus 0.5. So sum to infinity, that would be 8. So this is our final answer. The functions of f and g's are defined by this and this. Explain why the function fg does not exist. Fgx means that x will be put into gx first, then after that we will put them into fx. So now x is less than 0. This is the domain that you have to follow when you put into gx, and also whenever gx has to, in order for fx to exist, your gx has to be less than x. So we'll look at this part. Okay, in order for you to find out the domain, gx is less than 0, so you just replace gx is equal to x squared less than 0. So you can see that, okay, when you make x squared as a subject, so it will be x squared, which must be greater than infinity. So apparently there is no such functions. Okay, no such functions, so this shows that the function does not exist. Okay, x cannot be greater, and nothing can be greater than infinity, right? This shows that the function does not exist. Okay. Next one, given that the function gf does exist, ouch, find and simplify this expression for gfx. Say this function does exist. Okay. So meaning we can't use whatever they have given us over there. So gfx, just write it down. gfx, okay, gfx is a different functions. So g, okay, then we just have to replace everything in there. 1 divided by this whole thing, and then we have to square as well. Okay, this is going to be a bit disgusting. So I'm just gonna change this divide to multiply. So flip around whatever is on the inside, square, and simplify it. Simplify means that we have to expand it. 4x minus 1 square over 9x to the power 4. So that's going to be 16x squared minus 8x plus 1 over 9x to the power 4. Yes, that's it for gfx. It shows that f inverse can be written as px. Okay, this one clearly looks like the product from the quadratic formula, but let's see. So where p, q, and r are integers, so fx given to us is 3x squared minus 4x minus 1. Let's see. Let fx become y, then we'll do it. Y is equal to 3x squared minus 4x plus minus 1. So move the whole up to the other side. It's going to be 4x minus 1, 3x squared. So 4yx minus y is equal to 3x squared. So 3x squared minus 4yx plus y is equal to 0. Next, just use the quadratic formula. Since we are making x as a subject, so we have to just treat y like a normal constant. So x is equal to minus b, 4y plus minus b squared minus 4ac over 2a. So x, you will have 4y plus minus, okay, let me simplify the contents inside, 16y squared, 12y over 6. So now, we have to switch back everything so that it becomes f inverse. Everything now will change from y, become x over 6. So what do we do now? Okay, we can still simplify everything. 4x plus minus. Okay, it's 16 here, 12 here, so just factorize 4x. That would be 4x 3 over 6. 4x plus minus 2. So I'm going to take out a 4. It's going to be x 4x minus 3 over 6. But we are not done yet. So we can still simplify. Okay, be careful. Don't do this cross, alright? Don't do this kind of cross. So if you really want to factorize this kind of thing, you can do it slowly, like this. It's not even that slow. Just take out the common factor here too. 2x plus minus x 4x minus 3, and close the bracket over 6. Then you cross the denominator. So you only have 2x plus minus x 4x minus 3 over 3. That's it. Since x at the end must be less than 0, so we'll just take the negative regions here. So the only thing that you need from them is the negative one. So just might as well just show this. Show that tangent, okay, question number 10. Show that tangent x plus secant x can be rewritten as 1 plus sine x, 1 minus sine x. Okay, let's see what we can do inside here. So tangent you can convert to sine x over cos x, while secant you can basically convert to 1 over cos x. So you might as well just combine them from the get-go, 1 plus sine x over cos x. And then don't forget to expand it. You can rewrite them like this, cos square x So that would be 1 plus 2 sine x plus sine square x over cos square x. Okay, but do I need to do that? I don't think I need to expand it, so let's just ignore this step. But y, I can still convert this to 1 minus sine square x. Okay, 1 minus sine square x. And you know, base this one can actually be related to your difference of 2 square. That is a minus b, a plus b. So in this case, 1 minus sine square x can actually be further simplified into 1 minus sine x, 1 plus sine x. So split them up. So now, it's just cutting it, we have 1 plus sine x, 1 minus sine x, QED. Hence, solve the equation tangent 3 theta plus secant 3 theta equal to 6 from 0 to 180. So we have to use back what we have there. Technically, tangent plus secant, so the only thing that differs is the x. So how about we just replace this entire thing into 1 plus sine 3 theta, 1 minus sine 3 theta is equal to 6. So just move the entire thing to the other side, simplify further. We're gonna get 6 minus 6 sine 3 theta. So move everything, move the like terms together, negative 5, oopsie, that would be just 5. So sine 3 theta, it would be 5 over 7. Okay, so this will be based on this. Okay, so positive, sine positive will be first and the second quadrant. So find out the basic. The basic 3 theta will be sine inverse 5 over 7. Everything has to be in degree. Set to degree mode, shift sine 5 over 7. That's gonna give me 45.584. Okay, that's my basic. So now I'm going to actually start calculating 3 theta. Okay, at the first quadrant it would just be my basic angle, but at the second one I have to minus my 180. Okay, it's gonna be 45.84 and 180 minus 45.584. That's gonna be 134,406. Okay, now since our final answer will be divided by 3 anyway, so I would like you guys to check. Always be careful for another rotations, because you know that, in fact, oops, what did I press? In fact, this is our first quadrant, this is our second quadrant. Okay, there is always a possibility that we can rotate one round here. Okay, so I'm gonna do another thing that's like 134, using the first basic angle, but after 1 revolutions, that's gonna be plus 360 to check whether I'm still within the range of 180 or not, the domain. Okay, so theta, I'm gonna divide everything by 3 now. 104.46 divided by 3, so that's gonna be 360 plus 45.584 divided by 3. As you can see, technically we're still, hold on, that's gonna be 405,584. So we divided by 3. That's gonna give us 45.584 divided by 3, 15.2. And the other one, that's gonna be 44.8. And then this one is gonna give us, say, 405.584 divided by 3. That's gonna give us 135 and 2. So I don't think 134 and 416 plus 360 divided by 3. We're still in the game. Okay. So just be careful. You just take the entire this thing, okay, which is gonna be 494.416 divided by 3. So that will end up giving you 164.8. So the second revolution matters, guys. Make sure you check properly. Okay. In this questions, all length are in centimeter. The diagram shows a rectangle ABCD with BC is equal to x. The area given for the whole rectangle is 400 cm squared. 2 identical quarter, blah blah blah, x over 2. So this radius is x over 2. Okay, the area of the entire thing is 400. So given that x can vary, so definitely over dx, find the value of x that gives the minimum value of the perimeter. So dp over dx must be equal to 0, because it says of the perimeter, right? So first our task is to look for the side here, but how are we going to find it? So given that the entire area of the rectangle is 400 cm squared, right? So we could have done like xy is equal to 400, y is equal to 400 over x. So that means that the entire length from here to here is 400x, but we need only like a short part, okay, the part over here. So the part over here that's gonna be 400x minus x over 2. So that's gonna be the side, the longer side after deducting the radius. And then don't forget we have to find the arc length. So the arc length will be, the formula for arc length will be theta r. So you know that this is clearly 90 degree. So pi over 2 multiplied by the radius. That's gonna give us pi x over 4. That is for our arc length. So pi x over 4 on this side. And this is exactly half of the radius, x over 2. Okay. So x over 2 here. So the rest, this side will be just the same. So at the end of the day, just multiply by 2 and you get the answer. So the perimeter of shaded region, which I'll call it as P, will be x over 2 plus pi x over 4 plus 400x minus x over 2. The entire thing just multiply by 2. Okay, so then pi x, so that will be, this thing will cancel out, surely. So that's gonna be 2 pi x over 2 plus 800 over x. That's for perimeter. So dp over dx, that will be just pi over 2 and minus 800 over x squared. Okay, just move, remember when you're differentiating this, just move the x up due to the rules of reciprocal, then just move the power here and it'll be negative 800, but don't forget to minus the power by minus 1. So dp over dx, since we are looking for maximum or minimum stationary point, so dp over dx is 0. Okay, just let pi over 2 minus 800 over x squared go to 0. I think we can express our answer in the exact form. Is it possible? No, I don't think so because of the pi. But never mind. So just square root the entire thing over here. But surely you're just gonna take the positive part because there is no length with a negative value. So just take the positive value divided by pi. That's gonna be x equal to 22.567. So if you round it off, x will be 22.6. That is the value of x. Is it in cm? Yeah, just write it in cm then. But we're not done yet. We only managed to solve the minimum value for the parameter. Okay, that gives only the value of x. We need to find the minimum value of p. So you have to substitute back into the formula of p, which is p is equal to pi x over 2 plus 800 over x. So again, just plug the value in. That is 22.567. Okay, just make sure you guys, whenever you guys are writing it down, make sure you guys use the raw data because that's gonna give you the most accurate answer here. Over 22.567. Close it. Pi 22.567 and divided by 2 plus 800 divided by 22.567. So our total parameter, the minimum parameter that we can do is 70.9. Okay, round it off to a 3 significant figure. This will be your final answer. Okay, question number 12, we have vector in 2D. So the diagram shows a triangle OBC. So this is quite, this is the least favorite of all of our students here because they really give a lot of informations. OA to AB you have the ratio of 4 to 7. OD to OC you have the ratio of 4 to 7 as well. So let's mark it. OA, the ratio is 4. To the entire thing, that is going to be 7. Right? So you know that the ratio of OA to OB is 7. And OD is 4. And OC is going to be 7. OC is going to be 7. I just want to mark it real quick. Now, the point P is the points of intersections where AC and BD is such. Okay, since we have these two things here, this is the greatest hint provided to us, like what we're going to do next. So where lambda and mu are scalars. So you need to find expressions of OP in the form of B to C and also either mu or the lambda, and hence show that P divides AC and DB in a ratio of 4 to 7. Okay, so the first part we have to know which path do we need to take in order to find OP. So let's go ahead and refer to this. Since we are gonna use AP, so you definitely need to take this route. Okay, OA and AP. So you need the AP route. So OP will be OA plus AP. So the direction is very important. So you guys should know that whenever it's O, you should start from O and always end with the P and make sure the A in the middle, they can be connected. So OA given to us is 4. It's 4 over 7. So it's 4 out of the total 7 of OB, right? So that is obvious. It should be 4 over 7 B. So that is our OA. Okay, or A is 4 over 7 of B. Let's write it down. 4 over 7 of B plus AP. So given AP is lambda AC. So how do we find AC? So the route to AC apparently is AB plus BC, but we do not have either one of those things. Okay, or we can take AC. Basically, you can take this route as well. AO plus OC. So it's gonna be, since this is a reverse AO, so it will be minus 4 B plus, since OC is C, right? So just write it down, which is equivalent to 4 over 7 B plus lambda 4 B7 plus C. So this is our first expressions for OP. The next one. Okay, I'm gonna erase this so it's easier for us to see later on. And hold on, let me just clear all these things. Okay, now we have to find OP again, but which route should we take? So given to us that, okay, we have to use BP now. Okay, so which route will involve us using BP? That is going to be here. So that will be OB plus BP. So OP will be equal to OB plus BP. And we know the full OB will be equivalent to B, but we do not know BP, given to us that it's mu BD. So how do we find BD here? So BD, okay, the full length of BD, it's basically here. So we can basically go over by using BD is equal to BO plus OD. Right, so BO, the reverse BO should be negative B plus the OD. So how do we find OD in this case? OD is basically 4 out of 7 of OC. That is 4 over 7 C. So come back here, it would be B plus mu 4 over 7 negative B plus 4 over 7 C. Okay, so we have two OP now, hence we have to use both OP expressions to find. So you just relate this. Okay, the first one is equal to the second one. So this and this, just equate them together since they're both OP. 4 over 7B plus lambda, okay, plus C is equal to B plus lambda minus B plus 4 over 7C. Okay, so let's group B and B together. I think we can just move our scalar in as well. Just expand the scalar inside and we can see the next step here. So 4B over 7 minus 4 lambda B7 plus lambda C is equal to B minus mu B plus 4 lambda C over 7. So how do we do this? We basically using, we can use equating method. So just let the one with the B group together with the B. So you're going to end up with 4 over 7 minus 4 lambda over 7 is equal to 1 minus mu. Okay. As for the other one, you can just basically group this one with this one. So lambda will be equal to 4 mu over 7. That's the first equation that you have. So we can basically, okay, let me simplify this real quick. So mu will be equal to 4 lambda over 7, okay, plus 1 minus 4 over 7. Okay, I'm gonna simplify it. So that's gonna be 3, I guess, plus 3 over 7, right? Now, we just have to do simultaneous equations here. So just substitute 1 into 2. Then you'll get something new, which is 4 over 7 multiplied by 4 mu over 7 plus 3 over 7. So do it, 16 over 49 plus 3 over 7. Go ahead, 1 minus 16 over, oh, what am I doing here? 49. And can I change it to fractions? So that's going to be 33 mu over 49, which is equivalent to 3 over 7. So then, in order to find mu, just multiply by 49 over 33. So this is going to be 7 and 7 over 11. So our mu, I'm just going to write it here. So mu will be 7 over 11. Okay, that's the first one. And now what about our lambda? So we just have to replace the mu inside. Then you'll get lambda as 4 over 11. So are we done yet? Of course not, because we still have one final mission where we have to show both AC and DB is in the ratio of 4 to 7. So we have to rearrange these equations given to us that since we already have mu and lambda, so that's gonna be a lot easier for us to work with. So let me just replace this here. So last we have to find the ratio and prove that they are 4 to 7. And looking at this, we know that this is the lambda is a scalar of AC. Okay, lambda is a scalar of AC, so that means the magnitude of AC is going to be 4 over 11, and mu BD, okay, the magnitude is going to be 7 over 11. So to find the ratio of AC divided by BT, so we can have 4 over 11 divided by 7 over 11, so you can have 4 over 7. Prove it. There we go. The point P is such that OQ is equal to 2 over 7B plus 2 over 7C. Use a vector method to show that OQ and P are collinear. Collinear basically just means that, let me just show you one example. P here, Q here, they can be connected by a line, and then the main characteristic is they will often show a common vector, common directional vector. Okay, common directional vector. So what do we exactly mean by that? So let me show you right here. We just have to take one expression of OP. Okay, since they say OP and Q will be collinear, right? So I'll be taking one from OP, which is, can I just copy it? Okay, I think we can, right? Okay, I'm thinking of copying the entire thing. Okay, I guess we can. So let me just paste it. Yes, there we go. Okay, 4 over 7. Now, since I already have my lambda, so I'll be placing my lambda, which is set 4 over 11. I'm going to put it in, plus C. So I will have negative 16, B, 77 plus 4, C over 11. Let's see, what do we have here? 4 over 7, oh my goodness, minus 16 over 77. So I will get 4B over 11 plus 4C over 11. And then I can just factorize out the common factor, which is B plus C. There we go. This is what I mean by the common directional vector. Okay, if you don't believe me, you can take OQ, say, so take out the 2 over 7, and then you will see that they both share the same similar vector here. So this is what we mean by common vector. So if you can prove that they have both common vector, okay, then it basically shows that they are both collinear to each other. So OQ and OP are collinear due to common vector B plus C. Okay, so that's basically the end of the paper. I hope you guys have fun with your revisions, and I'll see you guys soon. Take care, bye bye.